This is how we measure electrical conductivity here at Ohio State University. The first thing is to look at the basics. The equation for determining electrical conductivity is sigma equals L over RA. Sigma is the electrical conductivity, Siemens per meter. L is the length between electrodes in meters. R is the resistance in ohms. And A is the electrode area in square meters. The first thing you need is an ohmic cell. Here's an example of one of ours. It has an electrode on either side and the cell in between. We'll put these electrodes in here and the sample will be in between that. And we know the area of these electrodes, and we'll measure the length after we have put the sample in. The next thing you need is an AC power supply. You need an ammeter and a voltmeter and a thermocouple meter. That system I just described is the simplest system for measuring electrical conductivity. We typically want the electrical conductivity as a function of temperature. To do that, we have extra components. The components that you need to do that would include a voltage and current sensor, a data logger, and thermocouple isolation modules.
Hi, my name is Samantha Ward. I'm an undergrad at The Ohio State University and I'm a student employee. I'm going to demonstrate how to take an electrical conductivity reading. First thing I'm going to do is demonstrate how to add product to the T-cell. The product we're using is tomato paste. The first thing you want to do is add the electrode to one end and then add the product into the T-cell. You want to make sure that there are no air bubbles in the product. Add the thermocouple probe into the sample.
Okay. That was good.
Turn on the AC power supply to heat up the sample. Read the volts and current and the specific temperature. Then we measure the length. Typically, we want the conductivity as a function of temperature. To do that, we use the data logger. You're looking at the data logger output. We will now turn on the power supply. Notice the temperature going up and the current going up. This is the setup used for conductivity as a function of temperature. First, the power supply is connected through to the voltage and current sensor. The volt and current sensor is connected to the T-cell. The volt and current sensor is also connected to the data logger, as well as the thermocouple isolation modules is connected to the data logger. The thermocouple from the thermocouple isolation modules is connected to the T-cell.